Hello there, and welcome to the Bedtime Lab, your cozy sanctuary for sleepy facts that guide you gently into the arms of sleep. Tonight, we're embarking on a wondrous journey through the universe, exploring the mysterious world of interstellar objects, with a special nod to the enigmatic Oumuamua. So, snuggle up, get comfortable, and let the soothing facts flow over you like a gentle lullaby. As we begin, feel free to share where you're tuning in from, as it's always delightful to know where our friends call home. Have you ever gazed up at the night sky and wondered about the travelers that wander the cosmos? Oumuamua, which means scout or messenger in Hawaiian, is one such traveler. It was the first known interstellar object to pass through our solar system, and it left astronomers with more questions than answers. Can you imagine the excitement felt when it was discovered in October of 2017, something truly unexpected and alien? Speaking of surprises, did you know that Oumuamua defied many of the expectations scientists had? Unlike the icy comets and rocky asteroids we're used to seeing, it exhibited none of the typical signs of a comet, such as a glowing tail. Instead, it seemed more like a rocky or metallic object. And here's something even more intriguing: its shape. While most celestial objects are fairly round or slightly elongated, Oumuamua appeared to be long and thin, resembling a gigantic tumbling cigar or a cosmic pancake, which is a shape never before observed in our neck of the cosmic woods. And here's another fascinating tidbit. Oumuamua traveled through space at an astonishing speed of about 80 to 5,000 kilometers per hour. Just imagine something whizzing through our solar system so fast, faster than any spacecraft we've ever built could hope to achieve. This speed suggested that it was not bound by the gravitational pull of our sun, affirming its status as an interstellar visitor. Another captivating detail is its unusual trajectory. Oumuamua's path was hyperbolic, meaning it was on a one-time visit, never to return. It came from the direction of the constellation Lyra, swooped through our solar neighborhood, and is now on its way out towards the constellation Pegasus. This transient journey left scientists pondering the many mysteries it carried with it. Let's talk about its origin. Scientists believe that interstellar objects, like Oumuamua, may be ejected from other star systems, possibly due to gravitational interactions or the birth pangs of new stars. Picture a stellar nursery where baby stars are born, flinging rocky material into the vast reaches of space, some of which might eventually find their way to us. Oumuamua also sparked lively debates about its true nature. Some scientists speculated it might be a fragment from a planet shattered in a distant star system, while others even entertained the idea of it being an alien probe due to its strange acceleration. The imagination runs wild, does it not, when faced with such cosmic enigmas? And speaking of its acceleration, here's a curious fact. As Oumuamua left our solar system, it appeared to accelerate slightly, as if pushed by an unseen hand. Some researchers suggested this could be due to outgassing, a common occurrence in comets where gases escape and propel the object forward. However, Oumuamua did not display any comet-like activity, leaving the reason for its speed boost a mystery. This brings us to an intriguing consideration about interstellar objects. They challenge what we know about the universe. Oumuamua's discovery has led scientists to rethink how common such interstellar visitors might be, with estimates now suggesting that our solar system could be visited by thousands of such objects every year, most of them too small or faint to be detected. Did you know that detecting interstellar objects is like finding the proverbial needle in a haystack? Space is vast, and these objects are often small and dark, making them incredibly difficult to spot. It's a testament to the keen eyes and powerful telescopes of astronomers that we've been able to glimpse these cosmic wanderers at all. And here's another thought to ponder. Oumuamua was only visible to us for a brief period before it slipped beyond the reach of our telescopes. This fleeting glimpse into the unknown served as a reminder of how vast and mysterious the universe truly is. It also underscores the importance of readiness in our observational capabilities, so that next time we might gather even more information. As we continue to explore these celestial wonders, it's comforting to think that there are countless stories flying through the darkness of space, each with its own tale to tell. Just like Oumuamua, they carry with them the secrets of distant worlds and the echoes of ancient cosmic events, waiting for us to unlock their mysteries. So, as you drift into a restful slumber, let your dreams be filled with the wonder of the cosmos and the possibilities that await us among the stars. Thank you for joining me tonight at the Bedtime Lab, where every fact is a gentle invitation to explore the universe from the comfort of your bed. Until next time, sweet dreams and starry nights. Let me share something interesting about the path these interstellar travelers take. Interstellar objects like Oumuamua can travel through space for millions of years before they intersect with a solar system like ours. Imagine the countless cosmic vistas they pass by, a journey spanning generations from a human perspective. As they wander, these objects remain largely unchanged, preserving the conditions of the time and place they originated from. It's like receiving a time capsule from a faraway world, frozen in time and space, waiting to be opened by the first eyes that glimpse it. Have you ever wondered about the frequency of such cosmic visitors? It's believed that our solar system could host many interstellar objects at any given time, yet we rarely notice them. This isn't because they're not there, but because they are so challenging to spot. Most are too dark, too small, or simply pass by too quickly. It's fascinating to consider that at any moment there could be cosmic travelers silently weaving their way between planets, unseen by our telescopes. Speaking of size, did you know that Oumuamua was estimated to be approximately 200 meters in length and about 35 meters wide? Its elongated shape was unlike anything we had seen before in our solar neighborhood. Most objects we observe, such as asteroids or comets, tend to be more spherical. This unique form only added to the intrigue and left scientists pondering how such a shape could naturally occur. Here's a fascinating fact about the color of interstellar objects. Oumuamua appeared to have a reddish hue when observed through telescopes. This reddish color is not uncommon in space objects. It's often the result of cosmic radiation altering the surface over millions of years. However, it still raised questions about the composition of its surface and its journey through the cosmos. What kind of conditions might it have encountered to acquire such a color? And here's something intriguing about their speed. While Oumuamua was moving at an incredible velocity, even faster objects likely exist. Some interstellar visitors may travel at speeds that allow them to cross the entire galaxy. These swift travelers could potentially offer insights into the dynamics of different star systems. Each object's speed and trajectory can reveal secrets about the gravitational forces they've encountered along their path. Now, let's consider the sheer distances involved. When we talk about interstellar space, even the closest neighboring star systems are light years away, unfathomably distant by earthly standards. Objects like Oumuamua remind us of the vastness of space, making the journey from one star to another seem like an epic voyage. In a sense, each interstellar object is an ambassador from its home system, carrying a piece of its origin story across the dark seas of the universe. Speaking of their origins, Scientists speculate that many interstellar objects may come from the icy outer regions of distant star systems. These regions, similar to our own Kuiper belt or Oort cloud, are vast reservoirs of comets and other icy bodies. Occasionally, gravitational disturbances can send these objects hurtling into interstellar space, creating potential travelers like Oumuamua. It's fascinating to consider how a gravitational nudge can set an object on a journey that spans the galaxy. Did you know that the study of interstellar objects could one day help us understand how common life-supporting conditions are in the universe? By analyzing the materials and isotopes present in these visitors, scientists hope to glean insights into the building blocks of planets and life elsewhere. Each object is a small piece of a larger cosmic puzzle, contributing to our understanding of the universe and our place within it. Another intriguing aspect is how interstellar objects like Oumuamua challenge our current technology and methods of study. The brief window of opportunity to observe them pushes scientists to develop faster, more sensitive instruments. This drive for technical advancement not only aids in our exploration of the cosmos, but also benefits many other fields of science and technology here on Earth. Imagine the potential for future missions that could intercept and study these travelers up close. Just like the missions to comets or asteroids in our own solar system, a mission to an interstellar object could provide unprecedented insights. While such a mission poses incredible challenges, the knowledge gleaned could be well worth the effort, offering us a glimpse into the distant corners of the galaxy. And finally, let's ponder the implications of these discoveries. Interstellar objects remind us that we are part of a vast interconnected universe. Their presence encourages us to look beyond our own solar system, fostering a sense of curiosity and wonder about what lies beyond the stars. Each discovery nudges us closer to answering grand questions about the nature of the universe and the potential for other civilizations out there among the stars. As you drift into gentle dreams tonight, think of these interstellar travelers as they forge paths across the cosmos, carrying secrets of distant worlds. Let the night sky inspire you, reminding you of the endless possibilities that lie beyond, waiting to be discovered. Have you ever thought about how interstellar objects like Oumuamua can help us understand the dynamics of our own solar system? These cosmic travelers offer a unique perspective by serving as natural probes, carrying with them traces of their journeys through space. Their paths can reveal hidden gravitational influences at play in our universe, much like how a leaf floating in a stream can tell you something about the current's speed and direction. Isn't it intriguing to imagine what their orbits might whisper about the unseen forces guiding them? Speaking of surprises, did you know that Oumuamua was initially thought to be a comet? Yet, it showed no signs of a tail typically associated with comets, such as outgassing when they approach the sun. This absence of a tail puzzled scientists and sparked debates about its true nature. Was it an unusual comet, or perhaps something entirely different? The mystery of its categorization adds a layer of complexity and excitement to its story. Imagine for a moment the temperatures these objects must endure. In the cold depths of interstellar space, they can experience temperatures close to absolute zero. Yet, when they venture close to a star, they must withstand the intense heat and radiation. This incredible range of temperatures could lead to fascinating changes on their surfaces, possibly triggering chemical reactions that would be impossible to observe on Earth. Can you picture the resilience required to survive such extremes? Now, consider this. While Oumuamua was unique in its own right, it is only the first confirmed interstellar object to pass through our solar system. Scientists suspect there could be countless others, each with its own story to tell. The sheer number of these objects out there suggests that interstellar travel might be more common than we once thought. This realization challenges our previous understanding and invites us to rethink the frequency and nature of such cosmic visitors. Have you ever wondered whether interstellar objects could bring with them exotic materials or elements unfamiliar to us? The prospect of discovering new chemical compositions offers tantalizing possibilities. By studying these materials, we might uncover new insights about the building blocks of distant worlds and perhaps even find clues about the availability of resources beyond our solar system. It's like opening a treasure chest filled with unknown gems, each one waiting to be examined. Let's talk about the potential for these objects to collide with planets. Although the chances are extremely low, the idea of an interstellar object impacting a planet presents an interesting scenario. Such an event could have profound effects on that planet's atmosphere and surface, potentially altering its environment in significant ways. It's a reminder of the interconnectedness of cosmic events and how even seemingly distant objects can have far-reaching influences. Did you know that interstellar objects like Oumuamua challenge our understanding of celestial mechanics? Their unusual trajectories suggest they might be influenced by non-gravitational forces, such as radiation pressure from starlight. This phenomenon is known as the Yarkovsky effect, and while it's a common factor for asteroids within our solar system, seeing it potentially at play in interstellar objects opens up new areas of research. It makes you wonder what other subtle forces might be at work in the universe. Another curious aspect is the idea that interstellar objects might serve as natural carriers of life. While it remains a speculative notion, some scientists ponder whether microbial life could survive an interstellar journey, hitching a ride on these cosmic vessels. If true, this could have profound implications for the theory of panspermia, which suggests that life can spread across galaxies carried by such objects. Imagine the implications of finding evidence of life in such a way. It would be a discovery that reshapes our understanding of life's potential distribution in the cosmos. One of the most surprising revelations is the potential for interstellar objects to help us map the galaxy's star-forming regions. By tracing their origins back to specific stellar nurseries, we can learn more about the conditions under which stars and planetary systems form. This knowledge helps fill in the gaps of our cosmic map, offering a clearer picture of the galaxy's structure and evolution. Isn't it remarkable to think that these travelers could guide us in charting the heavens? Finally, let's consider how observations of these objects may inspire innovation in space exploration technology. The challenges posed by their fleeting visits push us to develop new methods to detect and study them. This drive for innovation not only enhances our ability to explore space, but also influences technological advancements that can benefit life on Earth. From enhanced sensors to improved propulsion systems, the pursuit of understanding interstellar objects propels us toward a future where the stars are within our reach. As you reflect on these wonders, let your imagination drift through the cosmos, where each interstellar object carries a piece of the universe's grand tapestry. They are silent messengers, inviting us to listen closely to the stories they bring, stories of distant realms and cosmic secrets, waiting to be unlocked by curious minds. Let me share with you a fascinating aspect about interstellar objects. Their shapes can be quite peculiar. Take Oumuamua, for instance. This mysterious traveler puzzled astronomers with its elongated cigar-like shape, unlike anything typically seen in our solar system. Its unusual form led to many theories about its origin, suggesting it might have formed under unique conditions far from our view. Have you ever thought about the speed at which these objects travel? It's truly astonishing. Oumuamua zipped through our solar system at an incredible speed of nearly 300,000 kilometers per hour. That's like a bullet racing through space, making its journey swift and fleeting. Such speed suggests it had a long voyage through interstellar space before its brief encounter with our Sun. Speaking of journeys, the distances these objects cover are mind-boggling. They travel across vast stretches of space, often for millions of years, before crossing paths with our solar system. Imagine the cosmic stories they could tell, having witnessed the formation and death of stars and the rise and fall of planets, all while journeying through the galaxy. Did you know that scientists are developing special missions to study these visitors? The challenges posed by their fleeting nature have inspired concepts for spacecraft that could launch quickly and intercept interstellar objects on short notice. This would allow for close-up exploration and analysis, offering us direct insights into their composition and origin. It's a remarkable blend of readiness and curiosity driving this new frontier of space exploration. Now, here's an intriguing thought. Interstellar objects may hold clues about the early universe. Since they originate from beyond our solar system, they might retain information about the conditions present during the galaxy's infancy. By studying them, scientists hope to gain a glimpse into the past, piecing together the intricate history of the cosmos. Let's explore the idea of how these objects might interact with our solar system's environment. As they pass through, they can collect particles and gases from the solar wind, effectively carrying a sample of our solar neighborhood with them. This transient interaction provides a unique opportunity to investigate how our solar system's material might be transported across the galaxy. Can you imagine the possibility of interstellar objects altering their paths due to gravitational encounters with planets? Such interactions, while rare, could slingshot these objects into new trajectories, sending them off to different destinations on their cosmic journeys. Each encounter adds a layer of unpredictability to their travels, making their paths as unique as fingerprints. Here's a captivating notion. Some interstellar objects might actually be remnants of ancient collisions. These could be fragments of larger bodies that broke apart in cataclysmic events, ejected into space to wander the cosmos. Studying these pieces could reveal hints about the violent pasts of distant star systems, offering a glimpse into cosmic dynamics that shape the galaxy. And let's not forget the possibility of these objects being composed of exotic materials. Imagine finding forms of ice or minerals that are stable only in the extreme conditions of interstellar space. Such discoveries could expand our understanding of chemistry, pointing to processes that occur under conditions vastly different from those on Earth. Have you ever wondered how the presence of interstellar objects might inspire new theories about the galaxy? As new observations challenge existing models, scientists are prompted to rethink their understanding of star systems and the distribution of matter across the galaxy. This evolving perspective is a testament to the dynamic nature of science, where each discovery propels us further into the unknown. Now consider the potential for these objects to be studied using innovative astronomical techniques. Advances in technology allow us to capture detailed data about their trajectories and compositions, even from great distances. These techniques, such as spectroscopy, let us analyze the light these objects reflect or emit, revealing their chemical makeup and surface properties. Speaking of light, have you ever thought about how these objects can influence the brightness of stars? As they pass in front of them, they can cause temporary dips in starlight, a phenomenon known as a transit. Observing such events helps astronomers confirm the presence of interstellar visitors and provides additional data on their size and shape. Let me share another captivating perspective. The search for these objects is expanding our observational capabilities. By honing our ability to detect faint and fast-moving objects, we enhance our skills in astronomical observation, which can be applied to studying a myriad of celestial phenomena. This refinement of our tools and techniques enriches our overall exploration of the universe. Finally, imagine the stories these celestial wanderers might inspire in the human imagination. They remind us of the vastness and mystery of the cosmos, igniting our curiosity and sense of wonder. As we drift into dreams, these interstellar objects become the vessels for our imaginations, carrying us to distant realms and undiscovered worlds where the universe's secrets are waiting to be unveiled. In this way, they not only inform our scientific understanding, but also enrich our cultural tapestry, becoming part of the larger narrative of human exploration and discovery. And with each new discovery, we are reminded of our place in the universe and the endless possibilities that lie beyond what we see. When we think about interstellar objects like Oumuamua, it's easy to focus solely on their mysterious origins and swift passages, but there's so much more to uncover about these cosmic travelers. For instance, have you ever considered that the shape of these objects might be quite different from what we're used to seeing in our own solar system? Oumuamua, for example, has an elongated cigar-like shape, unlike the rounder asteroids and comets we're familiar with. Such unusual shapes might provide clues about the processes that formed them, hinting at different conditions or forces at play in other star systems. Here's a fascinating thought. The surface of interstellar objects might reveal secrets about their journeys across the galaxy. As they travel through space, they are constantly bombarded by cosmic rays, which can alter their surfaces over time. This means that by studying the outer layers of these objects, scientists could potentially read the history of their cosmic travels, much like deciphering an ancient manuscript written in the language of the universe. Did you know that interstellar objects could potentially hold organic compounds, the building blocks of life? These materials might be more common in the universe than we think, and their presence on objects from distant star systems raises intriguing possibilities for the distribution of life's ingredients across the galaxy. If such compounds are found, it could suggest that the seeds of life are being spread far and wide, carried by these messengers between stars. Speaking of stars, imagine the possibility that some interstellar objects may have originally been part of a planetary system before they were ejected into the void. This ejection can occur due to gravitational interactions or catastrophic events, sending them careening into interstellar space. Each of these objects might then carry a tiny piece of its home system with it, offering us a rare opportunity to study the building blocks of planets beyond our solar neighborhood. Here's an intriguing notion. The speeds at which these objects travel give us a window into the gravitational forces at work in the galaxy. Their rapid velocities suggest they are influenced by massive gravitational pulls, possibly from supermassive black holes or other dense regions of space. By understanding these speeds, we gain insights into the gravitational tapestry that weaves through the cosmos, shaping the movements of objects on a grand scale. Have you ever wondered about the possibility of finding interstellar objects in our solar system that have been captured by the sun's gravity? While it's a rare occurrence, it could happen that an interstellar object is pulled into a stable orbit, becoming a temporary or even permanent member of our solar family. Such a capture would be a significant find, providing prolonged opportunities to study them up close. Consider this. These objects can serve as natural time capsules, preserving the conditions of their birth environments. By analyzing them, Scientists might unlock secrets about the early stages of star and planet formation in regions far beyond our reach. This glimpse into the past could illuminate the processes that have shaped not only our own solar system, but countless others throughout the galaxy. Let me share something intriguing. Our understanding of interstellar objects is still evolving, and each new discovery has the potential to challenge existing theories about the universe. As we learn more about their composition, trajectories, and origins, we are constantly re-evaluating our models of how the cosmos operates. This dynamic and ever-changing nature of science keeps the field vibrant and full of potential surprises. You might find it fascinating that the search for these objects has sparked international collaborations among scientists. Teams from around the world are pooling their resources and expertise to track, study, and interpret the data collected from these fleeting visitors. This global effort underscores the universal human desire to explore and understand, transcending borders in the pursuit of knowledge. Have you considered that interstellar objects could provide insights into the conditions beyond the heliosphere, the boundary where the sun's influence wanes? As they enter our solar system, they traverse this boundary, offering clues about the transition zone between solar and interstellar space. This area, known as the heliopause, is a region of great scientific interest, and interstellar objects act as probes that can help us explore its mysteries. Here's a thought-provoking idea. The study of these objects might eventually lead to the discovery of entirely new celestial phenomena. As we refine our observational techniques and expand our search, we open the door to finding unexpected and never-before-seen objects, pushing the boundaries of what we know about the universe and its myriad wonders. Now, imagine the potential for these objects to inspire technological advancements in space exploration. The challenges they present are driving innovation in spacecraft design, propulsion systems, and observational tools. As we strive to understand more about them, we also enhance our capabilities to explore our solar system and beyond. Lastly, consider the role of public interest and imagination in the study of interstellar objects. These mysterious visitors capture the public's imagination, drawing attention to the broader field of astronomy and encouraging support for space research. They remind us of our innate curiosity and the desire to reach beyond our world, fueling dreams of exploration and discovery. In contemplating the journeys of interstellar objects like Oumuamua, we are not only exploring the universe, but also reflecting on our place within it. Each fact we uncover, each mystery we unravel, brings us a step closer to understanding the grand tapestry of the cosmos, inviting us to dream of the wonders that await in the starlit expanse. Here's something to ponder. Interstellar objects, such as Oumuamua, are not just fascinating for their origins and journeys, but also for their shapes. Did you know that Oumuamua is notably elongated, resembling a cigar or even a pancake, which is quite unusual compared to most objects in our solar system? This elongated shape suggests it might have a unique rotational pattern, possibly tumbling through space in a complex dance. Imagine how studying this movement can help us understand its physical properties and the forces that have acted upon it during its journey. Speaking of journeys, have you ever considered how these objects manage to survive the harsh conditions of interstellar space? They travel vast distances, exposed to intense cosmic radiation and extreme temperatures, yet they remain intact enough for us to study when they arrive in our solar system. This resilience hints at the sturdy composition of their materials, perhaps consisting of dense rock or metal that can withstand the rigors of space travel. What materials could be so durable that they endure the cosmic gauntlet and still reveal secrets to us? And here's an intriguing aspect. The surface features of interstellar objects can offer clues about their past. Imagine a surface pitted and scarred by micrometeorite impacts, or perhaps covered in dust accumulated over eons of travel. These features are like a timeline etched into their surfaces, providing a record of their encounters and transformations over millions, perhaps billions of years. By examining these surfaces, scientists can infer not only where these objects have been, but also the environments they have traversed. Consider this: the very presence of interstellar objects like Oumuamua in our solar system challenges our understanding of solar system dynamics. Their unexpected trajectories and speeds suggest they originate from regions of space where different physical laws might apply, or where the stellar neighbors exert distinct gravitational influences. This realization prompts scientists to refine existing models of celestial mechanics, pushing the boundaries of our knowledge about how stars and planets interact across the vast distances of the cosmos. Have you ever wondered about the diversity of interstellar objects? While Oumuamua was the first to be observed, many more may have passed unnoticed. These objects might vary dramatically in size, composition, and even color. Some could be icy, like comets, sublimating as they approach a star, while others might be rocky or metallic, with surfaces reflecting the light of distant suns. This diversity indicates a wide range of conditions in their parent systems, and each object we discover offers a unique insight into the multitude of environments beyond our solar system. Here's a fascinating thought: the possibility that some interstellar objects could harbor ancient magnetic fields. These fields, if present, would be relics of their formation environments and could provide valuable data about the magnetic dynamics of distant star systems. Imagine detecting a faint magnetic signature that tells a story about the processes at play in the nascent stages of a star's life, a story carried across the universe like a message in a bottle. Speaking of messages, could these objects hold clues about the chemical evolution of the galaxy? The mix of elements and isotopes found within them might reflect the regions they originated from, revealing processes that have shaped the galaxy's chemical landscape over billions of years. By analyzing their composition, scientists can piece together the galactic history and better understand how the building blocks of stars, planets, and even life itself have been distributed and transformed over time. Imagine the challenge of capturing detailed observations of these fleeting objects. They traverse the sky at incredible speeds, visible for only short periods before vanishing into the cosmic abyss. To catch a glimpse of their secrets, astronomers must act quickly, employing powerful telescopes and advanced technology to track and study them. This race against time drives innovation in observational techniques and fuels the development of new tools designed to help us keep pace with these swift travelers. Have you considered the potential for interstellar objects to impact our understanding of planetary system formation? By studying their compositions and trajectories, scientists can test and refine theories about how planets and stars form and evolve. These objects serve as natural experiments, providing empirical data that can confirm or challenge our current models and assumptions. Each encounter with an interstellar visitor is an opportunity to learn something new about the processes that govern the birth and life cycles of celestial bodies. And here's a surprising fact: interstellar objects might even influence the habitability of planets. If these objects are carriers of organic compounds, their arrival in a planetary system could seed nascent worlds with the essential ingredients for life, potentially kickstarting biological processes. This panspermia theory suggests a universe interconnected by the exchange of life's building blocks, with interstellar objects playing a vital role in spreading the seeds of life across the stars. Reflect on the potential for these objects to serve as stepping stones for future exploration. As we advance our spacefaring capabilities, interstellar objects could become targets for robotic or crewed missions, offering a tangible link to the vast unknown beyond our solar system. These missions would not only expand our reach into the cosmos, but also deepen our understanding of the universe's complexity and diversity. In contemplating these possibilities, we are reminded of the allure and mystery of the cosmos. Interstellar objects like Oumuamua capture our imagination, urging us to explore, learn, and dream. With each discovery, we peel back another layer of the cosmic onion, revealing new insights and invariably new questions that beckon us to continue our journey into the stars. Have you ever stopped to consider the mysterious journey an interstellar object like Oumuamua undertakes? These celestial travelers embark on epic voyages, crossing the vast expanse between stars. It's incredible to think that an object could wander for millions or even billions of years before finally passing through our solar neighborhood. The sheer scale and duration of their journey is a testament to the enduring forces of the universe, propelling them across cosmic seas with a certainty and purpose that seem almost poetic. Now, here's something that might pique your curiosity: the sheer variety of trajectories these objects can take. Unlike the predictable orbits of planets tethered to their suns, interstellar objects follow paths dictated by gravitational influences from multiple stars. Their trajectories are often hyperbolic, meaning they're on a one-way trip through our solar system, never to return. It's as if they are travelers on a cosmic voyage, each path as unique as a fingerprint, each a piece of the grand celestial dance choreographed by the gravitational ballet of the galaxy. Let me share an intriguing thought. The speed at which these objects travel is nothing short of awe-inspiring. Consider that Oumuamua was moving at around 95,000 kilometers per hour relative to the Sun. This velocity is necessary for it to escape the gravitational pull of its home star and journey across space. It's fascinating to think about the forces at play that can propel an object to such incredible speeds, hinting at dynamic and possibly violent processes in its home system. Speaking of origins, have you ever wondered where interstellar objects like Oumuamua might come from? One possibility is that they are ejected remnants from star systems similar to our own. During the chaotic early stages of star system formation, gravitational interactions can fling debris away into the interstellar medium. These objects could be fragments of planets, moons, or even failed stars, carrying with them the scars and secrets of their violent births. And here's a captivating concept: the possibility that these objects hold clues about solar systems vastly different from our own. By examining their composition and structure, scientists can infer conditions in alien environments. For instance, the high metal content of an object might suggest a system rich in metallic elements, or one that has undergone significant stellar processing. Each piece of data adds a stroke to the complex portrait of galactic diversity, broadening our understanding of what solar systems across the universe might look like. Have you ever considered the challenges involved in detecting these fleeting visitors? Despite their dramatic journeys, they can be incredibly faint and difficult to spot. Interstellar objects are small and often dark, blending into the backdrop of the cosmos. Astronomers must use sensitive instruments and advanced detection techniques to spot and track them, highlighting the ingenuity and persistence required to capture these cosmic voyages in the act. Here's another fascinating detail. The surfaces of these objects might offer a glimpse into the primordial conditions of the universe. Some researchers speculate that interstellar objects could be composed of material predating the formation of our solar system, preserved in the cold vacuum of space. If this is the case, they could provide a unique window into the processes that occurred in the early galaxy, offering clues about the building blocks of stars and planets. Speaking of building blocks, consider the potential for these objects to harbor organic compounds. The detection of such compounds would bolster the panspermia hypothesis, suggesting that life's ingredients could be widely distributed across the galaxy. Imagine the implications, the very seeds of life being shared between star systems, potentially giving rise to life in places we can only dream of exploring. Have you ever thought about the potential energy sources these objects might represent? If interstellar objects contain volatile materials, they could release energy through sublimation as they approach a star. This process is similar to what occurs with comets in our solar system, and it could offer a tantalizing glimpse into the resources available in other star systems, possibly fueling future interstellar missions. Consider also the intriguing possibility that some interstellar objects could be artificial in origin. While this remains speculative, the idea captivates the imagination. If an advanced civilization were to launch probes or artifacts into the vastness of space, they might resemble natural interstellar objects, passing through our solar system like cosmic messages waiting to be decoded. Finally, let's reflect on how these objects challenge our perceptions of the universe. Each discovery prompts new questions about our place in the cosmos and the myriad wonders that exist beyond our view. The study of interstellar objects not only enriches our understanding of the galaxy's complexity, but also serves as a reminder of the infinite possibilities that lie beyond the horizon. As we continue to explore and learn, we are drawn ever closer to the stars, each step revealing more about the extraordinary universe we inhabit. Imagine for a moment the immense distances traveled by interstellar objects. It's awe-inspiring to consider that these objects may have been on the move for millions of years before they ever grace our skies. Did you know that scientists believe Oumuamua, for instance, could have originated from a region of space about 26 light-years away? This vast journey hints at the incredible resilience and persistence of such objects, enduring the cold and emptiness of the interstellar medium. Now, here's something that might surprise you. The shape of Oumuamua is unlike anything we've seen in our solar system. Early observations suggested it might be elongated, perhaps cigar-shaped, with a length possibly 10 times its width. This unusual shape led to myriad theories about its origins, from being a fragment of a larger body to being shaped by processes we have yet to understand. Speaking of shapes, consider how interstellar objects might change as they travel. The forces they experience, such as radiation, collisions, and gravitational tides, could gradually alter their appearance, smoothing surfaces or even reshaping them entirely. It's fascinating to think of these objects as sculpted by their journeys, each one a unique expression of the environments they've traversed. Have you ever wondered about the surface composition of such objects? Interestingly, Oumuamua's surface was found to be reddish in color, typical of many objects in our solar system. This hue suggests a coating of organic molecules, perhaps the result of prolonged exposure to cosmic radiation. This similarity hints at shared chemical processes that might be common across the galaxy, painting a picture of an interconnected cosmic ecosystem. Transitioning from colors to temperatures, these objects endure extreme conditions. In the cold dark of space, they can reach frigid temperatures close to absolute zero. Yet as they approach stars, they can rapidly heat up. Such drastic changes might cause them to release gases or even disintegrate, providing brief but valuable insights into their composition. Did you ever think about the rotational behavior of interstellar objects? Oumuamua, for example, showed a curious tumbling motion rather than a smooth spin. This tumbling could be a result of complex gravitational interactions or collisions in its past, adding another layer of intrigue to its mysterious story. Here's a thought-provoking idea. Interstellar objects might carry with them secrets of magnetic fields from their home regions. If these fields were strong enough, they could imprint on the object, providing a record of the magnetic conditions of distant environments. This might offer a rare glimpse into the unseen forces shaping other parts of our galaxy. Imagine the significance of discovering an interstellar object with an abundance of ice. Such a find would be monumental, suggesting that water, a key ingredient for life, is not confined to our solar backyard, but may be widespread in the universe. Even if we can't directly observe the ice, its presence might be inferred from the object's behavior as it approaches a star. Let me share an intriguing possibility. Interstellar objects might act as natural probes of the interstellar medium. As they move through space, they could collect fine dust or other particles on their surfaces. By studying these particles, we might learn about the composition and dynamics of the vast regions between stars. Consider the potential that these objects could reveal about the history of other solar systems. By analyzing isotopic ratios within them, scientists might glean insights into the processes that formed them, offering indirect evidence of events such as supernovae or stellar winds that have shaped their home environments. It's fascinating to think about the technological feats required to study these cosmic visitors, from the ground-based telescopes that first detect them to the space missions that might one day chase them down. Each effort represents the pinnacle of human ingenuity and curiosity, a testament to our desire to understand the universe. Speaking of missions, imagine a future where we send spacecraft to rendezvous with these visitors. Such missions could sample their surfaces or even return material to Earth. The knowledge gained from such endeavors could redefine our understanding of the cosmos, providing a tangible connection to the distant reaches of space. Lastly, ponder the philosophical implications of these objects. Each one challenges our understanding of the universe, highlighting the vastness and diversity of the cosmos. They remind us of our small yet significant place in the grand scheme of things, inspiring wonder and a continuous quest for knowledge. As we trace their paths and unravel their secrets, we draw closer to answering the age-old question of whether we are alone or part of a greater, interconnected universe. Imagine, if you will, the thought of interstellar objects as cosmic time capsules carrying within them ancient secrets of the universe. These objects have traveled unimaginable distances, witnessing cosmic events and the evolution of galaxies. Did you know that Oumuamua and others like it have likely passed through numerous star systems, each encounter potentially altering their trajectory and surface characteristics? Such journeys could mean that these objects are not just carriers of their origin stories, but also of the environmental history of the regions they've traversed. Here's a fascinating thought. The path of an interstellar object such as Oumuamua can provide clues about its age. By understanding the gravitational influences it has encountered, scientists might estimate how long it's been traveling. This analysis could reveal whether it's a relatively young wanderer or an ancient relic from the early days of our galaxy, a tantalizing prospect for those seeking to understand the timeline of the cosmos. Consider this intriguing possibility. Interstellar objects might even be involved in panspermia, the hypothesis that life can spread between planets and star systems. If these objects have icy surfaces or contain organic molecules, They could potentially transport the building blocks of life across vast cosmic distances. It's a mind-boggling idea that connects the fate of planets and life itself to these silent travelers. Let me share this surprising fact. The faint glow sometimes observed around interstellar objects might not just be reflected sunlight. Instead, it could be caused by a phenomenon known as outgassing, where volatile substances on the object's surface are heated by starlight and released into space. This process can create a temporary atmosphere, or coma, much like that of a comet, providing scientists with vital clues about the object's composition and history. It's worth considering that the interstellar medium, the space between stars, is not as empty as it seems. These regions are filled with gas and dust, which can interact with passing objects. As an interstellar object moves through this medium, it might accumulate material or experience drag, subtly altering its course. Such interactions offer a unique opportunity to study the properties of the interstellar medium itself, serving as a moving laboratory for astrophysical research. Another captivating idea is that these objects could tell us about the gravitational dynamics of other solar systems. By analyzing their velocities and trajectories, scientists can infer the presence of unseen planets or the gravitational influence of stars they once orbited. This indirect method of studying distant solar systems opens a window into the complex gravitational ballet performed by celestial bodies far beyond our own experience. Did you ever think about the possibility of interstellar objects harboring exotic materials? Given their origins from different star systems, they might contain elements or isotopes not commonly found in our solar system. Studying these materials could enhance our understanding of stellar nucleosynthesis, the process by which stars produce heavier elements, and offer insights into the diversity of chemical compositions across the galaxy. Speaking of diversity, it's fascinating to consider the variety of shapes and sizes these objects might take. While Oumuamua captivated us with its elongated form, other interstellar visitors could resemble more familiar asteroid or comet shapes. This diversity could reflect differences in the formation processes and environmental conditions of their home systems, providing a comparative perspective on planetary formation. Here's a thought-provoking concept. Interstellar objects might serve as natural records of cosmic radiation. As they travel through space, they are bombarded by high-energy particles, which can alter their surfaces and interiors. By analyzing these radiation signatures, scientists could reconstruct the exposure history of these objects, offering a unique chronicle of the radiation environment of the galaxy over millions of years. Imagine the potential for interstellar objects to contribute to our understanding of dark matter. As they move through the galaxy, their motions could be subtly influenced by the gravitational effects of dark matter, the mysterious substance that makes up most of the universe's mass. By carefully tracking these movements, researchers might glean hints about the distribution and properties of dark matter, an elusive and captivating pursuit in modern astrophysics. Did you know that some interstellar objects might have once been part of a larger body, such as a planet or moon? Catastrophic events like collisions or tidal disruptions could have ejected them into space, setting them on a journey across the cosmos. The study of such objects can shed light on the violent processes that shape planetary systems, offering a glimpse into the dynamic and sometimes chaotic nature of the universe. Consider the possibility that interstellar objects might one day become resources for future space travelers. If they contain water ice or rare minerals, these visitors could serve as convenient supply depots for expeditions venturing beyond our solar system. This notion transforms them from mere scientific curiosities into potential stepping stones for humanity's journey into the stars. Reflecting on these mysterious travelers, it's remarkable to think about the technological advancements that allow us to study them. From powerful telescopes that detect their faint signals, to sophisticated analytical techniques that decipher their compositions, each step advances our understanding and brings us closer to unraveling the mysteries of the cosmos. As we continue to explore these enigmatic visitors, we stand on the brink of discoveries that could reshape our perception of the universe and our place within it. Imagine for a moment standing on an unfamiliar world, gazing at the night sky and watching an interstellar object silently drift by. It's fascinating to realize that such objects are not bound by the gravitational pull of any star, making their trajectories unpredictable and endlessly fascinating. These cosmic wanderers can travel at incredible speeds, often exceeding 30 kilometers per second. Such velocities can make them challenging to study as they pass through our solar system in the blink of an eye. Speaking of speed, let me share this intriguing fact. The velocity of an interstellar object is a key indicator of its origin. By analyzing how fast it's moving relative to the stars in our galaxy, scientists can deduce whether it comes from the relatively calm inner regions of the Milky Way or the more tumultuous outer regions. This analysis helps piece together the object's story, adding a layer of narrative to its flight through the cosmos. And here's something you might find surprising. The path of an interstellar object can be influenced by the gravitational pull of planets and stars it passes by. These gravitational interactions, known as slingshot effects, can significantly alter an object's speed and direction, sending it on entirely new trajectories. It's as if the object is playing a cosmic game of pinball, being nudged and pulled by the immense forces of celestial bodies. Delving deeper, did you know that some interstellar objects might be remnants of ancient solar systems long since disbanded? When stars die, they can eject debris that drifts through space, carrying with it the history of its parent system. By studying these objects, scientists hope to uncover the secrets of stellar life cycles and the conditions that led to their formation and eventual destruction. Another captivating idea is that interstellar objects could provide clues about the early universe. As they journey through space, they might encounter regions filled with remnants from the Big Bang. By analyzing the materials picked up during these travels, researchers can gain insights into the conditions of the universe shortly after its birth. It's a time capsule of sorts, preserving the ancient whispers of cosmic beginnings. This reminds me of the fascinating possibility that interstellar objects could harbor prebiotic chemistry, the foundational processes that precede the formation of life. Some scientists speculate that these objects, having traversed various environments in interstellar space, might carry complex organic molecules formed in the dense molecular clouds where stars and planets are born. Understanding these chemical processes could shed light on how life might arise elsewhere in the universe. Consider this: interstellar objects might one day serve as probes for understanding the vast distances between star systems. By tracking their paths and studying the forces acting upon them, scientists can gather data about the interstellar medium and its characteristics. This knowledge might prove invaluable for planning future interstellar missions, providing a roadmap for humanity's eventual journey to the stars. Here's a thought-provoking idea. The study of interstellar objects could contribute to our understanding of gravitational waves. As these objects interact with massive celestial bodies, they might generate ripples in space-time, Detecting and analyzing these gravitational waves could offer new perspectives on the gravitational interactions that govern the dance of galaxies and star clusters. And did you ever consider the potential use of interstellar objects as natural laboratories? Their diverse compositions and histories offer unique opportunities to test theories about the formation of the solar system and the evolution of planets. By examining their surfaces and interiors, scientists can validate or refine models of planetary science, contributing to a broader understanding of our cosmic neighborhood. It's also worth pondering the idea that interstellar objects could act as cosmic messengers, carrying information about distant parts of the galaxy. As they move through space, they encounter various conditions and materials, effectively sampling the environments of different regions. By studying them, we gather indirect data about the places they've been, expanding our knowledge of the galaxy without ever having to leave our solar system. Let me share this enchanting notion. Interstellar objects could be more common than we currently realize. Although only a few have been detected, improved observational techniques and technology might reveal a hidden population of these cosmic wanderers. Increasing our ability to detect and study them could unlock a treasure trove of data about the universe, further enriching our understanding of the cosmos. Imagine the potential for interstellar objects to reveal the presence of planets or moons around distant stars. As they travel, their paths can be subtly altered by the gravitational influence of nearby celestial bodies, hinting at their existence. These indirect detections offer a glimpse into the architectures of alien solar systems, expanding our catalogue of known exoplanets and their characteristics. And did you know that the study of interstellar objects can inform our search for extraterrestrial life? By analyzing the organic compounds they might carry, scientists can explore the potential for life elsewhere in the universe. These studies also inspire new hypotheses about the conditions necessary for life to thrive and how it might differ from life on Earth. Reflecting on these possibilities, it's clear that interstellar objects are much more than silent wanderers. They are cosmic storytellers, carrying with them the mysteries of the universe and inviting us to listen closely. As we continue to learn from them, we deepen our connection to the cosmos and our place within this vast star-filled tapestry. Let's muse over another intriguing possibility. Interstellar objects might have played a role in seeding life on Earth. It's a captivating thought that these cosmic voyagers could have delivered essential ingredients for life to our young planet. As they traversed the vastness of space, they might have carried complex organic molecules which, upon impact, seeded the primordial soup from which life emerged. This panspermia hypothesis remains a topic of much debate, yet it highlights the potential for interstellar objects to act as carriers of life's building blocks. You might find it fascinating to consider that the surfaces of these objects provide a unique record of cosmic radiation exposure over countless eons. As they journey away from any protective starlight, their surfaces are bombarded by high-energy particles. By examining these cosmic scars, scientists can deduce the duration of their solitary travels and gain insights into the harsh environment of interstellar space. Here's another thought-provoking angle. Not all interstellar objects are icy travelers like comets. Some might be rocky or metallic, remnants of planetary bodies that once orbited distant stars. Imagine a shard of an alien world finding its way into our solar system, offering a tangible connection to systems light years away. This diversity in composition can teach us about the materials available throughout the galaxy and how they differ from those in our own solar neighborhood. Did you ever wonder about the colors of interstellar objects? They can vary widely, depending on their composition and the space weathering they endure. Some might appear as dark, charcoal-like bodies, while others could gleam with a metallic sheen. These color variations provide clues to their origins and the cosmic forces they've encountered, painting a vivid picture of their odyssey across the stars. Speaking of visual characteristics, the shape of interstellar objects can also be quite surprising. Unlike the well-rounded shapes of many comets and asteroids in our solar system, some interstellar visitors, like the enigmatic Oumuamua, have elongated or even cigar-like shapes. This unusual form might suggest a turbulent past, possibly involving violent ejections from their original systems, and raises questions about the processes that shape such objects. And here's something to consider. The speed of interstellar objects as they pass through our solar system can be astonishing. Some move so quickly that they provide only a fleeting opportunity for observation before disappearing back into the depths of space. This rapid passage makes studying them a race against time, spurring the development of new technologies and strategies to capture as much data as possible during their brief sojourns. Reflect on this. The chemical composition of interstellar objects might differ significantly from those found in our solar system. By examining these alien materials, scientists can test hypotheses about the universality of certain elements and compounds, offering clues as to whether the building blocks of life are common throughout the galaxy or unique to certain regions. Consider the possibility that interstellar objects might occasionally collide with each other in deep space. These cosmic encounters, though rare, could result in the exchange of materials and even the creation of new objects entirely. Such events might contribute to the complex tapestry of interstellar matter, weaving together fragments from disparate origins into new forms. One more captivating thought: interstellar objects could hold clues to the mysterious dark matter that permeates the universe. As they travel through space, their interactions with this elusive substance might leave detectable traces, offering indirect evidence of dark matter's presence and properties. Unraveling these secrets could be key to understanding one of the universe's most profound mysteries. Imagine the potential for interstellar objects to offer insights into the history of star formation. By analyzing their compositions, scientists can trace back the elements they contain to the specific processes that created them in ancient stars. This stellar archaeology can reveal patterns of star birth and death, enriching our understanding of galactic evolution. Here's a surprising thought. The trajectories of interstellar objects can be influenced by the cumulative gravitational forces of entire star clusters. As they pass through these dense regions, their paths are subtly altered by the collective mass of the stars they encounter. This intricate cosmic dance can offer a glimpse into the dynamic nature of star clusters and their influence on interstellar matter. It's also worth considering that interstellar objects might help us refine our models of planetary system formation. By comparing their characteristics with the bodies in our solar system, scientists can test different theories about how planets coalesce from the dust and gas surrounding young stars. These comparisons might reveal new paths to planet formation that we have yet to imagine. Have you ever thought about the magnetic fields of interstellar objects? As they traverse various magnetic environments, they might acquire or lose magnetic properties, which can then be measured by scientists here on Earth. Understanding these magnetic signatures could provide new perspectives on both the objects themselves and the magnetic landscapes they journey through. Lastly, ponder the idea of interstellar objects being part of a cycle of cosmic recycling. As stars explode in supernovae, they eject material that eventually forms new stars and planets. Interstellar objects, too, might be part of this cycle, carrying ancient stardust that will one day contribute to the formation of new celestial bodies. This cosmic recycling highlights the interconnectedness of all matter in the universe, reminding us of the continuous cycle of creation and destruction that shapes the cosmos. Let me share something intriguing. Interstellar objects, including ones like Oumuamua, may have surfaces that act as time capsules, preserving ancient cosmic dust from their places of origin. This dust might contain particles that predate our solar system, offering us a direct glimpse into the materials present in the early universe. Isn't it fascinating to think that by studying these objects, we could potentially touch remnants of the universe's infancy? Consider this. Interstellar visitors may not always be solitary travelers. Some might have originated from binary or even trinary star systems. The gravitational dance of such systems could catapult objects into interstellar space, which might result in trajectories vastly different from those ejected by single stars. This adds another layer of complexity when trying to piece together their journeys across the cosmos. Here's a thought-provoking notion. The gravitational slingshot effect from stars or planets can alter the speed and direction of interstellar objects dramatically. This means that their paths are not just straight lines from their origin to their destinations. Instead, they weave intricate arcs, influenced by the celestial bodies they encounter, making their journeys not only long but also labyrinthine. You might be surprised to learn that interstellar objects can help us understand gravitational interactions on a grand scale. By observing how these objects move through different regions of space, scientists can refine their knowledge of gravitational forces at work between stars and within galaxies, providing insights into the dynamics of the universe we live in. Let me paint a picture for you. Some interstellar objects might carry with them the signatures of nearby supernovae. As they traverse space, they can pass through regions where massive stars have exploded, potentially coating them with telltale isotopes from these cataclysmic events. This would provide a rare opportunity to study supernovae remnants far from where they occurred. And here's something fascinating. The surfaces of interstellar objects might harbor exotic ices, unlike any found on Earth. These could include volatile compounds that freeze only in the frigid depths of space, offering a rare glimpse into the chemistry of cold interstellar environments. By analyzing them, scientists could expand their understanding of chemistry beyond the confines of our solar system. Think about this. The mysterious Oumuamua's unexpected acceleration as it left our solar system sparked numerous hypotheses, including the possibility of outgassing or even artificial propulsion. While the idea of alien technology is tantalizing, the anomaly underscores how much we still have to learn about these enigmatic travelers and the physical processes that affect them. Here's a captivating concept. The ancient cosmic rays that bombarded interstellar objects over millions of years could alter their atomic structures subtly. These changes might offer clues about the radiation environment of deep space, helping scientists to model the cosmic conditions across different parts of the galaxy. Speaking of cosmic phenomena, did you know that the collisions of interstellar objects with our solar system's bodies might occasionally create unique impact signatures? These signatures can be different from those left by local objects, providing a forensic trail that can lead back to their interstellar origins, further enhancing our understanding of these extraordinary visitors. Imagine this. The peculiar shapes of some interstellar objects might be the result of tidal forces exerted by massive celestial bodies they passed near. These forces could stretch and reshape them over time, leaving us with objects that are like natural sculptures, carved by the gravitational tides they once encountered. Here's another fascinating detail. These objects might possess thermal histories that are quite distinct from anything we observe within our solar system. By studying their heat signatures, scientists can infer the diverse thermal environments they've experienced, offering a window into the varied conditions of interstellar space. Consider the possibility that the internal structures of interstellar objects could be porous, allowing gases and liquids to migrate through them. This permeability might affect their trajectories and rotations, adding yet another layer of complexity to understanding their behavior as they move through the cosmos. Have you ever wondered about the potential for interstellar objects to carry life? While speculative, the idea that they might transport microbial life forms from one star system to another is a tantalizing possibility that scientists continue to explore. If life can survive the harsh conditions of space, these objects might play a role in spreading it throughout the galaxy. Reflect on this intriguing notion. The surfaces of interstellar objects could be covered in a layer of organic compounds formed through the interaction of cosmic rays with simple molecules. These compounds might provide essential clues about the prebiotic chemistry that occurs in space, helping us understand the pathways that lead to life's building blocks. Lastly, think about the technology we might develop in response to these fascinating visitors. The need to study them quickly and effectively could drive new advancements in space exploration, from faster telescopes to more sensitive spectrometers, allowing us to unlock the secrets of these cosmic interlopers and deepen our understanding of the universe. These wondrous possibilities remind us of the vastness and complexity of the universe, inviting us to keep exploring, learning, and dreaming about the interstellar journeys that connect us all. And speaking of journeys, imagine the paths of interstellar objects as they slice through the fabric of our solar system, carrying with them stories from faraway realms. These visitors, like Oumuamua, are perhaps the most intriguing travelers, offering us glimpses into the unknown. Did you know that the very speed of these objects can tell us volumes about their origins? Some interstellar objects zip through space at astonishing velocities, sometimes reaching speeds of up to 200,000 kilometers per hour. This incredible speed hints at the powerful forces that have propelled them, possibly influenced by the gravitational pull of massive stars or the remnants of their explosive deaths. Here's something you might find fascinating. Interstellar objects are often dark and non-reflective, making them difficult to detect. This dark facade is likely due to a layer of carbon-rich compounds that have accumulated over eons. When these objects come from the depths of space, their surfaces are altered by the relentless bombardment of cosmic rays, which weather them into shadowy travelers that are masters of disguise. Picture this. Beneath their dark exteriors, interstellar objects might harbor complex mineral structures formed under unique conditions. These minerals could provide a tantalizing record of the environments within alien star systems, offering clues about the elemental compositions of places far beyond our reach. Analyzing such minerals would be like reading the geological history of a world we've never seen. Did you ever stop to ponder the possibility of interstellar objects acting as cosmic messengers? Some scientists theorize that certain elements within them might have been forged in the hearts of ancient stars, carried across light years to reach us. These elements could give us a rare insight into nucleosynthesis, the process by which stars produce heavier elements, enriching our understanding of stellar life cycles. Consider the intriguing idea that these objects could contribute to the mass of our solar system in very subtle ways. When they pass through, they might deposit tiny amounts of exotic material, like dusting our cosmic neighborhood with fine particles from beyond. This interstellar dust might, in small ways, influence the composition of the atmospheres or surfaces of planets and moons in our solar system. Speaking of influence, Have you ever imagined the gravitational interactions between interstellar objects and our solar system's planets? As they pass by, their gravitational pull could slightly alter the orbits of smaller bodies, like asteroids and comets, adding a touch of chaos to the orderly dance of our celestial playground. Each encounter could ripple through the system, a testament to the interconnectedness of everything in space. Now, here's an intriguing thought. Interstellar objects might not always travel alone. They could be part of larger streams of material ejected from their home systems, moving through space like schools of cosmic fish. These streams could contain a wealth of information about the star systems they originated from, acting as drifting archives of interstellar history. Imagine this. Some interstellar objects might be remnants of ancient planets or moons that were torn apart by gravitational forces. These fragments could offer a glimpse into the geologic and atmospheric processes of worlds that no longer exist. By studying them, scientists can piece together the life stories of planets that might have once harbored oceans or even life. Here's a surprising fact. The shape of interstellar objects can vary wildly, from elongated cigar-like forms to irregularly shaped lumps. This diversity in shape is not just a curiosity, it can tell us about the forces that have acted upon them. For instance, elongated shapes might result from the intense gravitational stretching experienced when passing close to massive bodies, while more irregular forms could hint at violent collisions in their past. Think about the possibility that interstellar objects may carry records of magnetic fields from their original star systems. As they travel, they could retain traces of these fields embedded in their mineral structures, offering a snapshot of the magnetic environment of distant worlds. Studying these magnetic signatures might help us understand how magnetic fields influence the evolution of planets and their potential for supporting life. Have you ever considered the potential for interstellar objects to be time capsules of ancient cosmic events? Some may contain isotopes that were formed in the vast expanses of exploding stars or during cataclysmic collisions. These isotopes, with their unique decay rates, could serve as natural clocks, allowing scientists to date events that occurred millions or even billions of years ago. Here's a thought to ponder. Interstellar objects might play a role in the cycle of galactic ecosystems. As they journey through space, they could interact with gas and dust clouds, contributing to the formation of new stars and planets. In this way, these seemingly solitary wanderers are integral to the grand process of cosmic recycling, helping to seed the galaxy with the building blocks of new worlds. And finally, consider the idea that studying interstellar objects could be crucial for future space travel. By understanding the materials and conditions they endure, we can better prepare for long-duration missions beyond our solar system. These objects challenge us to think beyond our current horizons, inspiring new technologies and strategies for exploring the vastness of space. The more we learn about these mysterious visitors, the more we realize how much they have to teach us about the cosmos and our place within it. Imagine, if you will, the notion that some interstellar objects could be composed of materials that are almost entirely alien to our solar system. These exotic materials might be the result of different chemical processes that occur in distant star systems. It's a bit like discovering an entirely new recipe from a faraway land that uses ingredients we've never tasted before. What fascinating secrets these materials could hold about the diverse chemistry of the universe. Here's something to stir your curiosity. Interstellar objects like Oumuamua might be propelled by forces we don't fully understand. While we usually think of gravity as the primary force acting upon celestial bodies, some scientists suggest that radiation pressure from starlight could also play a role. This would mean that these objects are not only influenced by the push of gravity, but also by the gentle nudge of light itself. Can you imagine the sun's rays acting like cosmic winds, gently guiding these travelers through the vastness of space? Speaking of movement, did you know that interstellar objects might have incredibly complex rotational dynamics? Unlike most asteroids in our solar system, which tend to rotate in a relatively stable manner, these objects could tumble through space in unpredictable ways. This chaotic rotation might be caused by interactions with other objects during their journey, or even by the uneven heating from starlight causing them to spin erratically. It's as if they are performing a cosmic dance, each step determined by forces beyond our control. Consider this. Some interstellar objects could be remnants of gigantic collisions that occurred in their home systems. Imagine a massive planetary body being shattered into countless fragments, some of which are ejected into interstellar space. These fragments could then travel for eons, carrying with them the history of those cataclysmic events. By studying them, we could gain insights into the violent processes that can shape star systems, shedding light on the dramatic forces at play in the universe. Here's an intriguing possibility. Interstellar objects might be coated in organic molecules, the building blocks of life. As they journey through space, they could collect a thin veneer of these complex compounds, potentially serving as carriers of life's precursors. This brings to mind the tantalizing idea that interstellar objects might play a role in panspermia, the theory that life on Earth could have been seeded from the cosmos. Could these wandering emissaries be silent bearers of life's potential, spreading it throughout the galaxy? Now, ponder this. The paths of interstellar objects through our solar system could offer clues about the structure of our galaxy. By studying their trajectories, we might learn about the gravitational influences of unseen masses, like dark matter or rogue planets. In this way, these objects become cosmic breadcrumbs, leading us to a deeper understanding of the invisible forces shaping our galaxy. Did you ever think that interstellar objects might have formed in the icy outer regions of distant star systems? These frozen realms, far from the warmth of their suns, could give rise to objects with icy cores and volatile surfaces. As they approach a new star, like our Sun, these ices might begin to sublimate, releasing gas and dust into space. This process could create a temporary atmosphere or even a faint cometary tail, hinting at the frozen origins of these enigmatic travelers. Here's a thought-provoking idea. Some interstellar objects may have once been parts of larger planetary systems, orbiting their stars in stable configurations. Over billions of years, gravitational interactions might have disrupted these systems, ejecting certain objects into the interstellar void. By studying these wayward pieces, scientists could reconstruct the histories of these lost worlds, piecing together the stories of planets that once were. Imagine that the surfaces of interstellar objects could bear the scars of countless impacts from micrometeorites and cosmic dust. This constant barrage would erode and reshape them over time, creating unique surface features that are unlike anything we've seen in our solar system. It's as if each object is a canvas, painted by the universe's relentless forces, offering scientists a glimpse into the dynamic processes that shape the cosmos. Consider the possibility that interstellar objects might vary in composition not only between systems, but also within the same system. This diversity could arise from the different regions where they formed, with variations in temperature, pressure, and chemical makeup. By analyzing these compositional differences, we could gain insights into the complex environments that exist around other stars, adding to our understanding of the diversity of planetary systems. Reflect on this intriguing notion. Some interstellar objects may have magnetic properties influenced by their formation environments. As they travel through space, they could interact with the magnetic fields of stars and planets, potentially altering their own magnetic signatures. Studying these interactions might provide valuable information about the magnetic landscapes of distant star systems, offering clues about the processes that generate and sustain planetary magnetic fields. Have you ever wondered if interstellar objects could serve as natural laboratories for studying extreme conditions? These objects might experience intense radiation, high-speed impacts, and violent thermal changes during their travels. By examining them, scientists might learn how materials behave under such conditions, providing insights that could be applied to materials science and engineering here on Earth. Picture this. Interstellar objects could be carriers of ancient cosmic isotopes, acting as time capsules that preserve the history of their journeys. These isotopes could reveal information about the age and origin of the objects, as well as the environments they've traversed. It's akin to having a cosmic diary, carefully recording the passage of time and space, waiting for someone to decipher its secrets. And finally, consider the breathtaking idea that interstellar objects might one day become destinations for human exploration. As we venture deeper into space, these objects could offer unique opportunities for scientific study and technological development. By learning to navigate and study these travelers, we could unlock new frontiers in our quest to understand the universe, transforming distant dreams into tangible discoveries. Each interstellar object, with its mysterious allure, beckons us to explore the unknown, promising new chapters in the epic story of cosmic exploration. Let's delve into a curious thought. Interstellar objects like Oumuamua might be moving through space at velocities that exceed the speed of objects typically formed within our solar system. These extraordinary speeds suggest that they have been accelerated by powerful gravitational forces, possibly from passing close to massive stars or black holes in their travels. Imagine the immense energy required to catapult such a body across the cosmos, whispering tales of the intense gravitational dances they participated in. Now, consider this fascinating possibility. The trajectories of interstellar objects are not random wanderings, but could be charted paths influenced by the gravitational lanes within our galaxy. Just as highways guide cars across landscapes, invisible gravitational currents might direct these cosmic travelers on their journeys, occasionally guiding them into our solar system's neighborhood. Such insights could help us map the unseen gravitational architecture of the Milky Way. Here's a thought for you. Some interstellar objects might be largely composed of hydrogen ice, a material theorized to exist in the coldest regions of space. This exotic composition would make them behave differently when heated by the sun, potentially explaining why some objects don't display traditional comet-like tails. The idea of hydrogen ice is still speculative, but it opens up intriguing possibilities for what these objects might be made of. Have you ever imagined the complexity of the surfaces of interstellar objects? They could be covered in a layer of cosmic soot, a dark material formed from the interaction of radiation with organic compounds. This sooty veil might darken the surfaces, making these objects appear more like stealthy shadows against the backdrop of space, challenging our efforts to detect them. Reflect on this. While interstellar objects traverse vast distances, they might also act as collectors of galactic dust and particles. As they journey through different regions of space, they accumulate matter, each speck adding to their story. By analyzing these gathered materials, scientists can trace the paths they've taken and the environments they've encountered, offering a snapshot of the galaxy's diverse neighborhoods. Did you know that interstellar objects could potentially carry with them ancient water ice? Water is a fundamental ingredient for life, and its presence on these objects would suggest that water-rich regions exist beyond our solar system. This ancient ice could hold clues about the chemical makeup of distant star systems, enriching our understanding of cosmic chemistry. Picture this. Some interstellar objects might be survivors of ancient star clusters that have since dispersed. These clusters, once tightly bound by gravity, eventually break apart, flinging their members into the galaxy. By tracing the origins of these objects, we might uncover evidence of long-vanished stellar communities, piecing together the history of our galaxy's dynamic evolution. And here's a whimsical idea. Interstellar objects, in their long journeys, might pass through regions of space rich in complex organic molecules. As they travel, they could absorb these materials, possibly altering their own chemistry. This constant accumulation and alteration might make them something akin to cosmic chameleons, continually changing as they voyage through the universe. Imagine the possibility that interstellar objects could act as natural shields against cosmic radiation. Their dense, possibly metallic compositions might enable them to protect any life forms that hitch a ride, safeguarding them from the intense radiation that pervades space. This idea tantalizingly hints at the protective capabilities of these silent voyagers. Consider this intriguing notion. The very presence of interstellar objects in our solar system might suggest a greater abundance of such travelers than previously thought. It could indicate that our galactic neighborhood is more interconnected than assumed, with cosmic visitors regularly paying visits. Each encounter with such an object expands our cosmic perspective, offering glimpses into the richness of the universe. Can you envision the potential for interstellar objects to harbor unique isotopes not found on Earth? These isotopes could provide a wealth of information about cosmic processes and conditions that are otherwise inaccessible to us. By studying them, we could expand our knowledge of nuclear chemistry in the depths of space, revealing the atomic dance of the universe. Here's a thought-provoking idea. As interstellar objects traverse space, they might become magnetized by interaction with stellar magnetic fields. This magnetization could influence their trajectories, subtly altering their paths over time. By examining these magnetic signatures, scientists might gain insights into the magnetic properties of the regions through which these objects have passed. Finally, contemplate this. Interstellar objects could challenge our notions of what constitutes a planet, a comet, or an asteroid. Their unique characteristics and origins might not fit neatly into our existing categories, prompting us to broaden our definitions. This re-evaluation could lead to a more nuanced understanding of the diverse forms that celestial bodies can take, reflecting the vast and varied nature of the cosmos. Each of these insights into interstellar objects like Oumuamua invites us to reconsider our place in the universe, sparking curiosity and wonder at the cosmic mysteries that await discovery. These celestial wanderers, with their silent stories of distant realms, remind us of the endless possibilities that lie beyond our home world. As we continue to explore and learn, these objects whisper of the interconnectedness of the cosmos, urging us to look upwards with both humility and awe. Let me share something intriguing. Interstellar objects might exhibit unusual shapes, possibly elongated or even pancake-like, as was suggested with Oumuamua. Such shapes could result from their formation processes or from the gravitational stresses they experience during their travels. Imagine the cosmic forces that could stretch or compress them, molding them into these unexpected forms. These unique shapes can affect how they spin and reflect light, making them difficult to characterize accurately. Speaking of light, did you know that some interstellar objects might be coated in reflective minerals that cause them to glisten as they rotate? This shimmering effect can make them appear to flicker or pulse, a mesmerizing dance of light that might sometimes confuse our instruments and challenge our observational techniques. Here's another fascinating thought. These objects might be the remnants of planetary building blocks from long-lost solar systems. As such, they offer a peek into the planet formation processes that occurred around other stars, perhaps similar or vastly different from our own. By studying their compositions, we could learn about the primordial materials that might have seeded distant worlds. Consider the possibility that some interstellar objects possess highly eccentric orbits, allowing them to crisscross through multiple star systems over eons. Such grand voyages could expose them to a variety of stellar environments, enriching their surfaces with a tapestry of interstellar dust and ionized gases. Each passage near a star might add a new layer, a tangible record of their interstellar odyssey. Let me tell you this: the temperature on these objects can vary dramatically as they journey between the cold expanse of deep space and the warmer regions near stars. These fluctuations could lead to fascinating chemical reactions on their surfaces, creating exotic compounds not normally found in more stable environments. Can you imagine the rich chemistry that might unfold in these transient moments of warmth? Here's something else to ponder. Interstellar objects might occasionally be caught by the gravity of a star, becoming temporary satellites before being ejected once more into the galaxy. These brief periods of capture could allow them to exchange material with the host system, potentially seeding it with new compounds, or even helping to kickstart the formation of new celestial bodies. Did you know that the surfaces of such objects could act as laboratories for complex organic chemistry? Under the influence of ultraviolet light and cosmic radiation, simple molecules could rearrange into more complex ones, possibly even the precursors to life. This raises intriguing questions about the role these objects could play in spreading life's building blocks across the galaxy. Imagine this curious scenario. Some interstellar objects might contain tiny magnetic fields of their own. These fields could influence how they interact with solar winds as they pass through different star systems, subtly shaping their paths and the trails they leave behind. Another captivating aspect is the possibility that these objects could host temporary atmospheres formed by sublimation of volatile materials as they approach a star. These transient atmospheres might be fleeting, existing only for days or weeks, yet they could offer a rare glimpse into the dynamic processes occurring just beneath their surfaces. Consider the implications of this. Interstellar objects could harbor clues to the early conditions of the universe itself. If they formed shortly after the Big Bang, their compositions might include primordial elements, offering a rare window into the universe's infancy. Such ancient travelers could hold the secrets of cosmic history within their core. Reflect on this idea. While these objects are largely indifferent to the stars they encounter, their gravitational interactions can sometimes cause stars to wobble slightly. These subtle movements could provide a method for detecting interstellar objects indirectly, revealing their presence even when they remain elusive to direct observation. Speaking of subtle effects, imagine the gravitational influence they might have on planetary systems they pass through. Even small changes in a planet's orbit caused by passing interstellar objects could have significant long-term effects on the planet's climate and evolution, potentially even altering its habitability. Here's a thought-provoking possibility. Some interstellar objects could be rich in rare isotopes or metals, making them valuable resources for future space exploration and industry. If we could harness these materials, they might provide crucial components for building spacecraft or supporting long-duration missions beyond our solar system. And finally, think about this. The very act of observing and studying interstellar objects, like Oumuamua massa, expands our horizons and deepens our understanding of the cosmos. Each discovery adds to the mosaic of knowledge that helps us comprehend the vastness and wonder of the universe. These objects, with their quiet, unassuming presence, challenge us to look beyond our immediate surroundings and consider the broader tapestry of existence. In contemplating these mysteries, we are reminded of the delicate balance of forces that govern the universe and the endless possibilities that await exploration. As we continue to unravel the secrets of interstellar objects, we're not just learning about distant worlds, we're also discovering more about ourselves and our place in the cosmos. The journey of understanding is as boundless as the universe itself, and each new insight brings us closer to the stars. Let me share something intriguing with you. Interstellar objects like Oumuamua might be more common than we previously thought. Some astronomers suggest that for every few hundred long-period comets we observe, there might be an interstellar visitor among them. This presents a tantalizing possibility that the galaxy is teeming with these silent voyagers, each with a unique story to tell. Imagine a universe where interstellar objects are the messengers, each carrying an ancient tale from a distant star system. Speaking of tales, did you know that Oumuamua's trajectory hinted at an unexpected acceleration as it left our solar system? This curious behavior led scientists to speculate about possible explanations, ranging from outgassing to less conventional theories involving light pressure. This unexpected twist challenges our understanding and invites us to explore new scientific frontiers. Could it be that these objects hold secrets about the mechanics of space travel that we have yet to uncover? Another surprising fact is that the surfaces of these celestial travelers are often coated in a thick layer of organic-rich material, sometimes referred to as space tar. This dark, carbon-rich layer can obscure their true nature. Imagine the potential these surfaces hold for harboring complex organic materials that, under the right conditions, might even contribute to life's ingredients across the cosmos. Let's consider the possibility that some interstellar objects might carry with them the remnants of ancient atmospheres or oceans from their parent systems. If they originated from a once habitable world, they could hold the frozen traces of water or gases trapped within them. Such a discovery would provide a remarkable insight into the conditions that might have existed on worlds orbiting other stars. Here's something to ponder. The shapes of interstellar objects can be as varied as their origins. Some might be elongated, like Oumuamua, while others could be more spherical or irregular. These varied shapes are often the result of their journeys through different gravitational fields and collisions with other objects in their home systems. Each shape tells a unique story of survival and adaptation in the harshness of space. Are you aware that some scientists are considering the possibility of launching missions to intercept and study these objects as they pass through our solar system? Such missions could provide unprecedented data on their compositions and origins, offering a literal hands-on approach to understanding our galactic neighbors. Imagine the possibilities of what we could learn from such close encounters. Interestingly, interstellar objects could also act as natural probes of space-time itself. As they traverse through the galaxy, their paths might be influenced by the presence of dark matter or other exotic phenomena. By studying their trajectories, we could learn more about the unseen forces that shape our universe. This presents an exciting opportunity to explore the fundamental mysteries of space physics. Have you ever considered that interstellar objects might serve as time capsules, preserving the history of the universe in their very makeup? If some of these objects originated from the earliest epochs of galaxy formation, they might contain pristine samples of the materials that constructed the first stars and planets. Analyzing such samples could provide invaluable insights into the dawn of cosmic time. Here's a thought-provoking notion. Some interstellar objects could be remnants of shattered planets or moons, ejected from their home systems by cataclysmic events. These fragments, wandering through the vastness of space, offer a glimpse into the dynamic and often violent processes that can occur within solar systems. Studying these remnants might reveal the fate of worlds unlike our own, altered by the dramatic forces of nature. Imagine this: the dust trails left by interstellar objects as they pass through star systems could contribute to the formation of new stars and planets. These trails act as seeds, gathering more material as they drift through the cosmos. In this sense, interstellar objects are not just wanderers, but also facilitators of creation in the universe. Consider, too, the idea that some interstellar objects might be composed of materials that are rare or even unknown on Earth. Such exotic compositions could have formed under conditions that don't exist in our solar system. By studying these materials, we might unlock new possibilities for technological advancements or gain new perspectives on the diversity of planetary systems. It's fascinating to think that these objects could also help us refine our models of star system evolution. By comparing interstellar objects to known comets and asteroids within our solar system, scientists can test and improve their theories about how solar systems form and evolve over time. Each new discovery brings us closer to understanding the processes that have shaped our cosmic neighborhood. And here's a final thought to leave you with. The very act of observing these interstellar travelers requires us to look beyond our immediate surroundings and expand our vision to the stars. As we strive to understand these mysterious objects, we're not just uncovering the secrets of the galaxy, we're also exploring the depths of our own curiosity and imagination. In this endlessly vast universe, every interstellar object is a reminder of the infinite possibilities that lie beyond our familiar horizons, inviting us to dream and discover.